a bunch of parts by a friend who wanted us to develop a smartwatch. As you can imagine, trying to actually build a smartwatch is near impossible for 3E students with no money and limited time. Yeah, it doesn't attach to wrist actually. Not only are the electronics hard to design to be, if you've ever torn open a real smartwatch, everything is designed to be extremely compact and all on one little tiny board. And so not only is the electronics hard to design, I don't even know how I would begin to do the materials of actually making a casing and stuff like that. So basically ours is a proof of concept like many others in this class. We have a screen here, and we're going to show you a little demo of what it does.
So the three fundamental things that we implemented were being able to keep track of time, doing Bluetooth notifications with a phone, and then the last one was wireless charging. So as far as software goes, the two things that, I'm the CPE of the group, so I did most of the software stuff. And so I implemented the timekeeping was pretty easy. Basically when it starts up, the code has an initial time that you have to set right now. Unfortunately, I wasn't able to sync it with like an external clock. I would need another piece of hardware for that. And so it just uses the Arduino millis function. As soon as it starts up, it uses that to keep track of the seconds and keep count. If you look closely, it's kind of set up like a typical phone today where they got the top bar on top. And then it just shows the time with seconds and then the date next to it. And it was actually kind of difficult to do that with the LCD only because it's not as simple as you would think to update like a spot on the screen with a digit and like just tell it to keep updating that. You have to actually rewrite over the entire portion of the screen that digit covers and then rewrite the next digit on top of that. So that kind of made it a little unnecessarily difficult. But once I got it, it was pretty simple.
Yeah, and that's just the problem with the Arduino libraries.
Yeah.
That it doesn't automatically update. You have to rewrite it.
Yeah, so
you can imagine it's somewhat difficult to make a nice fluid UI with Arduino.
Yeah.
And an LCD.
So the middle module here is just the Bluetooth shield. All these parts are obviously Arduino Uno specific. So the Bluetooth shield's in the middle, then the LCD screen's on top. This was an added.
We'll explain that in a second.
Okay, I'll stick with the software for now. So just to demo the Bluetooth notifications. So let's see, on the phone I had to install an application. In order to get any sort of communication from an external device with your cell phone, you need to have some sort of proprietary software on the phone. So I was able to actually find this open source software that is able to communicate from an Android phone to an Arduino. And so we kind of took that code and I changed it up a little bit to serve our needs to be able to update the LCD screen. And so you'll hopefully see when I send an email to, this is Eric's phone, so when I send him an email,
look at my pictures.
It should pop up with a new message. So give me one sec. Let's see if I can send a message. We'll give it like 5 seconds to give it a chance to actually receive the message on the phone. It's sort of another limiting factor. Nice. So boom, popped up, new message. And then just to show that the capacitive touchscreen works as well. Again, it was just minimal functionality, that's what we wanted to achieve. So if you looked closely, I could tap these colors on the bottom and it switches the color that's selected, and that just changes what the new message color would be when it pops up. So yeah, that's pretty much as far as software goes.
The guy also wanted this to be able to, the battery that it used to power it to be wirelessly charged, so he gave us this inductive charging set. So I kind of rigged a little janky setup here. So you have your transmitting coil, which takes 9 volts DC, and I'm pretty sure these are 555s on here because it generates, I think, a 1.2 something kilohertz wave that circulates through here, generates a oscillating magnetic field, and this receiver coil will pick up that field, produce an EMF, and charge the battery. Which I had to, I cut a micro USB cable and salvaged the power lines and cut the data lines off to make it nice and easy to charge the battery. So if we turn our power supply on at 9 volts, should be good. And then we place the coil over. They're fairly directional. You can see that, and you can place things between them. It makes no difference to the charger, but they're fairly directional. They have to be almost perfectly aligned, and the distance is like a couple centimeters. So they're definitely non-ideal. It basically have to be a contact pad. But the battery can be wirelessly charged, and if I can get this connector off, so I can
It's pretty hard to unplug that.
yeah. And then this actually will, I also have to, so this is a 3.8 volt battery. They don't make 5 volt batteries. And so to charge, to run this system off 5 volts, I had to get a little boost converter. And this, this will power the board. Yeah, that's incredible, right? So a lot of this project actually ended up being just research into how manufacturers and big companies like Apple and Google and Samsung make their smartwatches. All of the electronics are, as you can imagine, heavily customized to the application. And so the batteries are tiny, the coils are all fit in, all of the processing is all on board. And we would have liked to use some sort of operating system like, I don't know, I think somebody in here had a Pebble one, like a Pebble OS or like an Android OS to do the software stuff, but that didn't work out, so that's what we came up with.
So basically, it has the 3 functionalities of the screen displaying with the time, Bluetooth, and then the wireless charging, which were the 3 main prototypes that we're trying to get at.
Which actually turns out to be inconvenient because you have to disconnect the battery and plug it into a. I could have spliced these wires and done some extra stuff, but yeah.
Lots of there.